So hello everyone. In this video, we are going to talk about like how can we express our Boolean expression in CMOS logic. Okay, so how can we do that? So for that, we need to discuss about more of DPP logic, which I told you in previous video. Make sure you watch the lecture number 1. Okay, so in this video, हम थोड़ा सा डीपीपी के बारे में डिस्कस करेंगे what DPP means and we will create one lookup table. Okay, so D stands for dot, P stands for like PMOS, and this P stands for parallel. Okay, so based upon this I would like to create some table. Okay, and this table would be like a lookup table. Okay, so for example, if I am having a dot, okay, and then I am having a PMOS, then what would be my answer? If I am having a dot, then if I am having a NMOS, then what would be the answer? Uh, and if plus is there, PMOS is there, then what would be the answer? And if plus is there and NMOS is there, then what would be our answer? Okay, so only the thing which we have to know is कि हमारा DPP क्या है. ओके, अगर आपको ये चीज़ पता है कि DPP क्या है, then we can create like D for dot, P for PMOS, then here it will come parallel. Similarly, अगर dot NMOS के लिए होगा तो फिर series आ जाएगा, just reciprocal of this. Similarly, अगर dot PMOS के लिए parallel था तो प्लस PMOS के लिए क्या हो जाएगा, सीरीज बच जाएगा. ओके, एंड अगर डॉट NMOS के लिए सीरीज था तो प्लस NMOS के लिए पैरेलल बन जाएगा. Okay, this is like you can use your common sense and you can create this lookup table. I can rename it as lookup table. For me it is my lookup table. Okay, now based upon this let's do one question. Okay, so in this video we will going to see how can we implement this uh, Boolean expression through CMOS logic. So the same thing we need to perform. We need to do step 1. And what is the step 1? We have to take the complement on both sides. Okay, let me erase this. So we have to take complement on both sides. So what will happen after taking complement on both sides? Okay, here we can apply the De Morgan theorem. So what would be the De Morgan theorem? It would be like A bar plus B bar, and this plus would be converted into dot, and here it would be like C bar ka bar plus D bar. Okay, so we can simplify it further to get this expression. So bar bar will get cancelled. Okay, and we will get C plus D bar. Fine, and this is our what? Y bar. Okay, now question says that implement this through CMOS logic. Okay, हमें इसको CMOS logic के through implement करना है. So if you are familiar with CMOS logic, then you might be knowing what is like CMOS logic. So in CMOS logic, two blocks are there, or we can say that two networks are there. So PUN stands for pull-up network and PDN stands for pull-down network. So they both are serially connected, and in between them, our output is there. PUN is connected to VDD, pull-down is connected to ground, and this is made up of PMOS, and this lower one is made up of NMOS. Okay, in this way they are connected, and now we have to implement this Boolean algebraic expression through this logic. So what we will do, first we will try to create pull-up network, then second we will try to create the pull-down network. Now for creating a pull-up network we have to use PMOS. So we have to implement this expression using PMOS. So for PMOS, we will see, like for PMOS, we are having two things like here. Okay, two things we are having. So what can we do? In PMOS, this plus expression is there. So A bar plus B bar plus operation is there. Basically, plus operation means what? Basically, plus operations means what? It is a OR. And this dot is means what? This is AND. This is OR. So these are some basic operations which need to be like known. Okay. And how can we do like further proceed? So for further proceeding, what we can do, we can go to the lookup table and we can uh, see like for PMOS what should be our condition. So for OR, which means plus, what would be our PMOS? So PMOS is there, PMOS is there. So here is a plus. So it is connected in series. So we can get कि हमारा जो ए बार है और बी बार है दोनों प्लस में है और PMOS में ये दोनों सीरीज में कनेक्ट होने चाहिए. So here I can draw. This is my A bar. Sorry, this is my B bar, and they both are connected in series. Similarly, C or D भी plus में है. Sorry, C plus D bar is in series. So they would be in series because ये भी PMOS है और plus operation से connected है. Sorry, I'm using plus operation, but for just sake of convenience, I'm using it because actually in the actually they are OR operation. Okay, so ये OR operation से connected है तो ये क्या हो जाएगा? C and this would be D bar. But overall अगर मैं कहूँ कि ये मेरा जो entity है, let's suppose it X, ये मेरा जो भी entity है, let's suppose it Y, they both are connected in dot. So if two entity are connected in like dot, then what would be like our operation? So अगर dot पे है, so we go to the dot and हमें PMOS से बनाना है, so they would be in parallel. Okay, so in what way these both connections would be there? In the parallel way. Okay, so you see like everything I'm taking up from the lookup table, and on the top we can create it to VDD, and I can leave like this. So this is basically my pull-up network. This is basically my pull-up network. Now I am going to like create a pull-down network. So you can do by going to lookup table. One short trick is there is like if A bar and B bar are connected in series in PMOS, so in NMOS they would be connected in parallel. So I'm just going to connect in parallel. Okay, so they would be connected in parallel. Similarly, our C and D bar, they both would be connected in parallel. Okay, now these both and these both, they both are connected in parallelly. So in NMOS they both would be connected in serially. I hope this is clear to you. This would be my ground. At the top is VGD connected, and one thing which we like to mention is V out. So this is my V out. Okay, so this would be my V out, and this would be my pull down network like PDN. So हमने क्या करा, हमें कोई भी एक्सप्रेशन मिलेगा, वी विल परफॉर्म आवर स्टेप वन. एंड व्हाट इज स्टेप वन? हमें वाई बार निकालना होगा. वाई बार निकालने के बाद से वी विल गेट सम एक्सप्रेशन लाइक दिस. आफ्टर दिस वी से लाइक कि कौन से और से कनेक्टेड है, कौन एंड से कनेक्टेड है. वी कैन गो टू आवर लुकअप टेबल. और ये लुकअप टेबल बना कैसे था? डीपीपी लॉजिक से बना था, जो कि हम प्रीवियस वीडियो में देख चुके हैं. सो इफ यू आर नॉट गॉन थ्रू वीडियो, यू शुड गो एंड या यू विल गेट दिस. सो लुकअप टेबल आप बना लोगे. लुकअप टेबल बनाने के बाद से you can like solve this, and you will get ultimately our CMOS logic. So this whole thing, okay, this whole thing is my CMOS logic. Okay, so fine. अभी के लिए इतना ही. Till then, keep learning, keep watching. Thank you.